Okay, let's take a look at this. Stream form influences stream function. Okay, so remember those two words, form and function. We're going to say that the form affects the functions. So much of how a stream is going to function, is going to act, is going to do, has to do with how much sediment and what size of sediment it can transport. Okay, so in this example, we have a little braided stream channel near some glaciers that's bringing a ton of sediment down with it and depositing a lot of sediment. In this example, we have a river in a narrow canyon in Yellowstone National Park, and it is going to be carrying sediment somewhere else and not depositing it right there. So these processes really are called sediment production, where it produces sediment. When it carries sediment, that's the transport. And then when it drops that sediment, that's the storage. So the production is dependent upon what the parent material is. Parent material would be the type of rock that the soil came from, or the type of soil or rock that the sediment comes from. Erosion, where that's occurring and when that's occurring, vegetation type, coverage, land use, etc. So production, we're talking production of sediment in a river system. The transport and storage depends mostly upon how much energy is in the system. So we talked about energy being really important because it affects so much of what fish need, and this is why, because it has to do with what that river can do with the sediment. Okay, so let's look at some zones within a watershed system. Just so you're familiar with this terminology, you have your source reach. That is where the material, the sediment, is coming from. And so usually that's adjacent to a stream or at the headwaters of this stream, but it's where the sediment is getting picked up. And when sediment is coming from the land, we call it colluvial material. Once it is in the water, and then the water then redistributes it somewhere else, we would call it alluvial material. So you've probably heard of alluvial fans. That is land that has been deposited, or sediment that was deposited by rivers, and kind of often that's spread out in a fan-shaped pattern, and that's where we get that word. Okay, your transfer reach are the stretches of the streams that don't change their shape with increase or decrease in sediment, because the amount of sediment entering into the system is the same amount that is leaving that system or that reach of water. And then you have a response reach. This has large changes in the morphology or the shape of the river because of the sediment loads. So usually sediments get deposited in these reaches, and therefore because that sediment is getting dropped out or deposited, you're going to see changes in the river and its shape, and you're going to have those depositions happening both in the river and in the floodplain of the river. Okay, so let's look at the sediment transport capacity. That's the amount and the size of sediment that the river has the energy to support. So what would that be determined by? And if you just stop and think about it for a minute, when can a river carry more stuff, right? So it can carry more stuff when it's moving faster and when it's deeper. It'll drop more stuff when it is not moving as fast or there is not as much water. Okay, then we need to look at the channel morphology or the form of the river. Remember, we said that the function affects the form. So in this picture right here, obviously we have a lot of deposition. So this would be a response reach of this river, and all of this silt that was carried down this glacial stream is getting deposited. And in fact, that's been happening for so long that we have a really, really wide area of deposition from the river that is the response reach, and it's dropping out all of that sediment because it's lost its energy. Okay, so the morphology being the shape of the river. We've talked a little bit now that the channel morphology can be determined by whether or not sediment is getting picked up or dropped out. So the land around the river can influence the morphology. The slope of the river will influence the morphology of the river. how connected that river is to the floodplain will affect the shape of that river. The depth of the river will also affect the shape. That one's a little harder to picture. How fast the water is moving and how much sediment it's carrying. So we've talked a little bit about this last one here. So when we talk about the geomorphology, geo being land, we want to know what about the shape of the land around the river is going to influence the river. And we have three different situations here. This is what we call a confined channel. We have the land on both sides of the river is very steep, very rocky. It's not very likely to change in a short amount of time from the river. And so this river then has to go where the land lets it go. It's a confined channel. On this end of things, though, we have an unconfined channel. This would be a river that's highly connected to its floodplain. If we get more water, it's likely to just exceed its banks and widen out. Whereas here, if we get more water, it's just going to get deeper and kind of stick to the same path. And then we have these in between where we have both an unconfined on one side and a confined on the other side. So we call that a partially confined channel. And why this matters is because the geomorphology will then influence what that river can do. Okay, the slope or the gradient. Why does slope matter? Well, with slope comes speed, right? A steeper slope will have a faster velocity to the point where at some points there's just straight drop-offs and it's driven solely by gravity. It may influence how deep the water is because it's going to be able to scour the bed of that river a little bit more. It can influence how much energy is in that stream. That goes back to what we were talking about, that steeper slopes will usually have higher amounts of energy. And then we look at the connectedness to the floodplain. So when the channel is connected to the floodplain, all that energy that's in the river can dissipate when that water exceeds its banks. Instead of just continuing to rush down, it can dissipate outside of the banks during flood stages. And when a channel dissipates energy, it drops whatever it's carrying. And so therefore, in this case, as I've said, in these unconfined channels, you'll get the deposition occurring. And that produces some really fertile soils. And that's why we have these areas around river floodplains that are so fertile, because time and time again, all the sediment from upstream got transported down the stream and then deposited in the floodplain during a high water event. Velocity and depth is important because it is determined by the slope and the discharge, or the amount of water moving through. So when you have a steeper slope, you're going to have higher velocity. Discharge is the amount of water coming through. It determines the sediment transport capacity. So how fast it's moving and how deep it is, or how much water is in there, determines how much sediment that river can support. So up until now, we've been saying that the stream form affects the function, right? If it's moving, if the form is steep and fast and straight, it's going to carry sediment. It's going to deposit it when it's flat and connected to the floodplain. Well, now we want to look at the flip side of things and said, well, maybe it's the function of the river then that determines the form. And it is a little bit of a which comes first, the chicken or the egg, because in truth, they both affect each other and they drive each other. So if we're looking at how the function influences the form, we're going to say, well, the sediment transport capacity may influence the shape or the form of the river. And that has to do with the sediment load. Okay, so a suspended sediment load would be any sediment, no matter how big or how small, that is suspended in the water column and therefore moving with the flow of the water at the same speed as the water. The bed load would be the things down here on the bottom of the river. So all of these rocks are part of the bed load. It's whatever's on the bottom. So the size of the bed load and how fast that bed load is moving will eventually affect the form of the river. And then the dissolved sediment, that is important too. So all of these are parts of the sediment load. You can have it suspended, it can be part of the bed load, and it can be dissolved. You may not be able to see it at all. That dissolved sediment load is still really important. So all of these relate back to the sediment transport capacity. How much can that river carry? So will the river erode more sediment or deposit more sediment? Let's look at situations where each might occur. If the sediment capacity, or what it can hold, is greater than the load, what it's currently holding, then it's going to try and pick up more sediment because it wants to reach this point of equilibrium, and therefore it will end up eroding the banks. If the sediment capacity, what it can hold, is less than what it is currently holding, then something has to fall out of that water and stop being carried by the water, and then it will get deposited. If the capacity equals the load, you're not going to have any net change. You won't have it eroding or depositing. Okay, so this is called Lane's balance, and it is a great visual for picturing whether or not a stream is going to deposit sediment or pick up more sediment. And the fancy words for that are degradation, and you could think of it as erosion over here. And so if this scale swings in this direction, it's going to pick up more sediment or erode the land around it. If it swings in this direction, we're going to aggrade or deposit sediment onto the land next to the stream or in the bottom of the stream bed itself. So what would cause this balance or this pendulum right here to swing one direction or the other? So when everything is in equilibrium, the amount of sediment is equal to basically the amount of water, the energy available to carry that sediment, then nothing's happening, right? The capacity is equal to what it's currently holding, and so it's perfect balance. We have no degradation and no aggradation happening. But if this bar here maybe gets moved out to the end, we could picture then this scale tipping and therefore this pendulum swinging to the aggregation side. And so in that case, if this gets scooted out, then we're going to have things deposit. And we would scoot this out if we added maybe larger material to the river, to the sediment load. And if that's the case, then we would have some of it getting deposited. If we scooted it into the smaller stuff, scooted this bar in and filled our tray with small stuff, then it's going to swing this way and it's going to try and pick up more sediment to carry with it. Okay, let's look over here at stream slope. If we go steeper and move this bar out to the right, what's going to happen? Everything tips. We end up degrading, or we grab more sediment from the banks and we have more erosion occur. If our stream flattens out, if the stream flattens out, then the pendulum's going to swing this way and it's going to deposit or aggrade the sediment. So you can see here that it is just this balance between what it wants and how much it can hold, or how much it is currently holding. So it's all a matter of what's possible on whether or not it's going to degrade or aggrade. So where will this deposition and erosion take place? Well, in a straight channel, right? It doesn't make any bends. It's just going to head straight downstream, and it probably isn't going to deposit any material until it levels out and the slope lowers, and so it can deposit that material. Think about the pendulum swinging back this way. Okay, but in a meandering channel, now it might deposit that material on the inside of each turn. So the faster moving water cuts the bank on the outside, it aggrades it. It slows as it makes this bend, and this inside channel then deposits it, while the outside of the water is still moving fast, and it grabs more sediment, and then the inside stuff gets laid down, the outside stuff keeps grabbing more, and on these meandering channels you end up getting sandbars on the inside bends, and you get erosion occurring on the outside bends. So stream morphology